All right, so I'm Tashiana, and we are going to be talking about today volume of irregular shapes. And this is coming from the Kaplan packet in advanced geometry if you want to refer back. So what we're going to be talking about is what makes an irregular shape. We'll also look at the steps in finding the volume of those irregular shapes, and then throughout we'll practice problems to get better at it. So first of all, what are irregular shapes? So, okay, sorry about that. So what are irregular shapes? So they're combined shapes that are made up of two or more geometric figures that we'll already know, and they form this new shape, and it could be any type of structure. So to find the volume of the shapes, we first want to take that figure and break it into parts. And then we want to find the volume of each part, and then we could take those volumes, add them together, and get the total volume of the irregular shape. Okay, so, what am I doing? Here we are. So here's an example. We have this container over here, and they want us to find the volume of that container. So the first step you want to do is figure out which shapes make up that container. So looking at this, we have a cone at the top, and then we have a cylinder. So looking at the bottom, you see this circular base that lets us know that we're dealing with a cylinder and a cone because we have that circular base there. So a cone and a cylinder. So then the next step will be to find the volumes of each of the shapes using the volume formulas. So the formulas you won't have to memorize, they'll give them to you on that formula sheet. You just have to know how to use them. So looking at the first shape, which is the cone, I'm going to use the volume formula for the cone, which is 1/3 times pi times r squared, which is our radius, times the height of the cone. So I'm going to plug in those values. So 1/3 pi is always 3.14. Our radius in this case is 1. And remember, this circular base, because it's a cylinder, it's also a circular base up top and the base of the cone. So that radius is the same. So that's 1, and we square it times the height. Now you want to be careful here, because the height is not the entire height of the figure. It's just the height of this cone, which is 1.5. So when we calculate that, we get 1.57, and that's the volume of the cone. So then we'll do the volume of the cylinder, which is pi r squared h. So of course we know pi is always 3.14. Our radius again is 1, and we square it. And then the height is just the height of the cylinder, which is 2. So once we calculate that, we get 6.28 for the volume of the cylinder. And then our next step is to add the volumes together to get the volume of that entire container. So we'll be doing 1.57 plus 6.28, and that'll give us 7.85. And hopefully you can see that at the bottom there. So that tells us that the volume of the container, the entire container, is 7.85. So as you can see through this example, we can take two different shapes in this case, because the container is made up of two, find the volume of each shape, which we did here, and then we can add them together to get the total value of the container. Okay, so let's do another problem. Okay, so now we got this weird shape here, and they gave us some values, so we need to find the volume of that entire shape. So first we need to figure out which shapes make up the figure. So in this case, I have a cylinder again. Even though it looks a little different, I still have those two circular bases. And then this bottom block is a rectangular prism. So those are the shapes that I have. So now I need to find the volumes of each of those shapes. So starting with the prism, the volume formula is pretty simple. It's your length times your width times your height. So in this case, the length of the prism is 11, the width is 11, and then the height is 2. Because remember, it's just of that shape, not the entire thing. So when we multiply those together, we get 242. In this case, it was just units, so that's the just units squared. But the most important part is the number. And then the volume of the cylinder, we use that same volume, that cylinder formula, which is pi r squared h. So pi stays the same, it's 3.14. Our radius in this case, we kind of got to do a little calculation to figure it out. So it's not 2, 2 is our height. That's how tall the cylinder is. So here they gave us 10. And what this 10 represents is the diameter. So that's across the entire circular base. But we need the radius. So if you remember a little bit with basic geometry, the radius is half of a diameter. So in this case, the radius is 5. 10 divided by 2 is 5. And then we square that, we get 157 as the volume of the cylinder. So then our final step, we add those volumes together. So 242 plus 157, and we get 399. So the volume of the entire figure is 399. So I'll give you a minute to look that over, and then we'll move on. Okay. So the next problem, we have a slab of concrete. We'll have 4 concrete blocks in each corner as shown in the drawing below. So we got a slab of concrete, 4 blocks in each corner. If each corner block has the same dimensions, what is the volume of the structure in cubic feet? So they want to know what the volume is of the entire structure. So we start off the same. We figure out which shapes make up the figure. And in this case, we have all rectangular prisms. So that helps us a little bit because we use the same volume formula, which is length times width times height. So starting with this larger block, so that slab of concrete on the bottom, I'm going to plug in my values for volume. So the length of that is 12. The width is 8. And then my height here, remember, it's just the bottom larger block. So the height is just 3. It's not 3 plus 2, just 3. When I multiply those together, I get 288. So now I want to do the volume of the block. Same formula, length times width times height. So when I plug in those values, I get 3 for my length, 3 for my width, and 2 for my height. And it's just 2 because it's not the entire structure, it's just this one block. So 3 times 3 times 2, we calculate that, we get 18. So you would think usually we would be done, right? But in this case, we have 4 corner blocks. So that 18 is just the volume of one of them. So we have to take into account all 4. So in that case, you'll do 18 times 4, because that'll give us the volume of all 4 blocks, which is 72. So now we do like we did before. We'll add 288 plus 72, and we get 360. So in this case, your answer would be D. So just to repeat that a bit, that little extra step we had, when we did the volume formula, we just got the volume of one block. But in the structure, we have 4. So we have to take that volume that we found, multiply it by 4, and then whatever answer we get, then we add those together. So in this case, it was 72, and then we added to the volume of the larger block, which was 288, and we got 360. Okay. So Let's move on. So now we want to find the volume of the ice cream cone shown below. So first step is always the same. Let's figure out what shapes make it up. So we have a cone, even though you can't see the circular base of the cone, it's a cone. And then we also have a sphere. So then we find the volumes of each of those shapes. So the volume of the cone, this is the formula again, it's 1/3 times pi times the radius squared times the height. So I'll plug in those values and I get 1/3 times pi, which is 3.14. My radius, sorry about that, my radius is 1.5 and we square that. And then my height of the cone is 6.5. Excuse me. Once we calculate that, we'll get 15.3. So that's the volume of our cone. Next, we need to find the volume of the sphere, which is 4/3 times pi times our radius cubed, so to the third power. So when I plug in my values, pi, of course, is 3.14, our radius is 1.5, and I cube that, and I get 14.13. So typically we will be done. However, this part, the ice cream part, isn't an entire sphere. It's actually half of it. So because it's half a sphere, or hemisphere as we like to call it, we'll take that volume of the sphere that we found and we'll divide it by 2 because it's just half. And that'll give us 7.065. So now we'll add the 15.3 and the 7.065, and we'll get the volume is 22.365. So I'm not sure if you can see that or not, but we add those two volumes together. So sometimes you may have an extra little step, but the same way we solve the problem is not going to change. You still figure out the shapes that you need. We find the values of each shape using their formulas. We may have an extra step in there depending on how the figure looks. We add the volumes together, and that'll give us the volume of the entire shape. Give you a minute to look that over. Okay, let's go on. So now we have three identical rectangular boxes are stacked one on top of another. So we got 1, 2, 3. The total height of all three boxes is the same as the width of one box. The length of the boxes is 18 inches and the width is half the length. What is the combined volume in cubic inches of all three boxes? So it's a lot of words. So let's break it down a bit. So the first step is always the same. Figure out which shapes make up the figure. And in this case, we have rectangular prisms, all three. Okay. Next step, we want to find the volumes of each shape using the formula. So the volume of a rectangular prism is length times width times height. So now let's break down those words a bit. So looking at the problem, they said the total height of all three boxes is the same as the width of one box. The length of the box is 18 inches and the width is half the length. So I'm going to start with what they gave me, which was the length. So I know the length is 18 inches. So that's my first part. Then they tell me that the width is half of the length. So if my length is 18, I could do half of 18, which is 9. So that's my width. So now I need to figure out my height. So they said the total height of all three is the same as the width of one. So if I just figured out the width is 9, then the height of all three, which is equal to the width of one, is equal to 9. So now that I have all three values, I have my length, I have my width, I have my height, I can multiply them together to get 1,458 cubic inches, which will be A. So I'll give you a minute just to kind of look through that. So just to repeat that one little extra step, we kind of had to break down the words. So they told us that the height of all three boxes was the same as the width of one box. So that if the width was half of the length, which they told me the length was 18, so I know the width is 9. And if the height is equal, if the height of all three is equal to the width of that one, then the height is also 9. So sometimes we have to like really break apart the problem to see what we can use to figure out the problem. So the volume here, after we calculate those, so we'll do 18 times 9 times 9, that'll give us 1,458. Okay. I believe that was the last problem, yes. So in summary, to find the volume of irregular shapes, and we just did some problems, we'll break those figures that they may give us into the parts, which are the geometric shapes we know. And then using the formula sheet that they'll give you, because you won't have to memorize it. So using those formulas, once you know the shape, you'll be able to use the volume formula, and you'll find the volume of each part. And then once you find the volume of each part, you'll add them together, and that'll give you the total volume of the irregular shape. So I hope that helped. So that's no matter what kind of shape, no matter what it looks like, just looking at it and being able to break it apart is the most important, because then you can find the formulas off your formula sheet, and then you can find those volumes that you need and add them together. So hopefully that helped out. And yeah, take care.